So today I'd like to demonstrate some examples, drawing some examples of 1-point, 2-point, 3-point perspective. Perspective is a mathematical way of creating the illusion of three-dimensional space on a two-dimensional surface, first developed during the Renaissance. Rather than me just drawing at the beginning, let's look at some examples from the Renaissance. In this painting, you can see the blue lines denote that center horizon. On the horizon, that center point is the vanishing point. And basically this colonnade is a rectangle that has become a cube in 1-point perspective. So all four corners of this rectangle recede to the center vanishing point. It's similar here in the center, if you notice, it's similar if you were to stand on railroad tracks and look in the distance, and railroad track edges don't actually meet, but with 1-point perspective it seems as if the edges connect at that vanishing point, and the horizontal lines of the railroad track keep getting closer and closer and closer until it recedes at that vanishing point. So in the Renaissance, they were developing this idea of this 1-point perspective. Here's another example of another painting with a center vanishing point. The architecture follows that vanishing point on both sides. So this is basically a cube, this architecture on the right-hand side. This makes a square, rectangular shape, and it vanishes in that center vanishing point. So this is basically on the left and the right. The architecture are basically cubes that recede to one center vanishing point. So that is 1-point perspective. Here's another painting with this vanishing point right in the center. The architecture on the left is basically a square in 1-point perspective. The architecture on the left side of the composition is a square here, the side of the cube, vanishing at that center vanishing point, and again, like railroad tracks, vanishing into the center. And the last example, famous painting, Leonardo's Last Supper. The table is not a square, but a long rectangle parallel to the picture plane. The right edge is vertical, the left edge is vertical, but each corner recedes back to a vanishing point on the horizon line that happens to be directly behind Jesus' head. The walls of the architecture follow and recede to that same vanishing point. Same with the ceiling. And of course the apostles are the composition is arranged to coincide with that 1-point perspective. Okay, so let me draw a few examples. What we're going to start with will be the horizon line, and I'll just pick a point here and draw that horizon line. And our point of view can either be above or below the horizon line. What I'm going to do is first we'll draw a simple cube in 1-point perspective. So to do so, we'll create something, our point of view will be down below the horizon line. I'm going to draw, I'm basically going to draw a cube. We'll draw a square. If I was using a ruler, I would get this perfectly square and parallel. I'll do my best here. And close enough. So we have that square. And we will pick a point on the horizon line. I'll just pick a point right here as our vanishing point. And you'll notice each of the corners go back to that vanishing point. We can decide how far our cube goes back, and we'll just say right about there. And this back edge would be parallel with the front edge, and the back vertical side would be parallel with the front vertical side of the cube. And that would be a simple cube in 1-point perspective going back to the horizon line, the vanishing point on the horizon line. Now to draw a square in a cube, in 2-point perspective, rather than just a simple flat plane rectangle or square parallel to the picture plane, we're going to be looking at the edge. And I'll do it down a little lower here. We're going to be looking at the vertical edge of our cube. Actually, let's move it over a little bit. So this will be our vertical edge of our cube. And that will go to a vanishing point to the right. To another vanishing point on the left. And we can decide how far does our cube recede, and we'll say to right about there. And then this would go back to that vanishing point. And if this is the right edge of our cube, we'll say right about there. And that recedes to that size. We can then draw our cube. Again, the edges would be vertical and parallel to the front edge. We'll go right here. And there we have a cube drawn in 2-point perspective, a little lower on the picture plane. And we could do something really extreme and draw a 3-point perspective. This is quite a distortion. It would be as if you're in a city like Chicago or New York and you're standing really close to a skyscraper and you're looking up, and it practically is distorted and doesn't even seem to be at right angles at the top. And we'll draw something up here above the horizon line, and we'll do that in 3-point perspective. So if this would be the top corner of the building, let's say, we'll put it right here, and it might actually go downward to a vanishing point even off our drawing. We'll just do it down here at the bottom. Okay, and top of our building might go down. We'll even go to the same vanishing point right here, and do something right about there. And we'll figure how far does our cube or our building recede. And I'll say right about there, and it might go down to the vanishing point here, and here. And if it went all the way down, it might be a building that starts here, but if it's a floating cube, maybe it would go to, let's say, there. its other vanishing point. And here would be the lower corner to the vanishing point, and this lower corner. Because it's floating above the horizon line, we could see the bottom of this cube. So if this is the top corner, there you can see that distortion. I'll show you an example of that when I show some other artwork later, a Salvador Dali painting that's a hypercube cross, which has that very similar kind of distortion. But for now, this is 3 different examples. On the left we have a 1-point perspective. It's a flat plane with the edges that recede to 1 vanishing point, 1 point perspective. Here's a cube where you start with that vertical edge, the top and the bottom, and the right side goes to 1 vanishing point, the left side goes to another vanishing point to create a 2-point perspective. This one is below the horizon line, Here's a 3-point perspective above the horizon line, where you have that front edge, and it sort of is distorted because it's so extreme. It's like looking upward at a skyscraper. And because this is above the horizon line, you can begin to see the bottom edge of this cube. It's almost like a crystal. Now for the assignment, I want you to do several short, quicker drawings and just get the hang of 1- and 2-point perspective, for example, a little 3-point perspective. And once you get the hang of that and understand that simple cube, we're also going to look at value and tonality. What I ultimately want you to draw this week is a 60-minute drawing of a surreal kind of landscape where you have this horizon line, you're drawing cubes, and I'll explain in more detail in the syllabus, but the idea is this is an invention, a surreal kind of landscape, and I'll give some examples in another video of the kinds of surreal landscapes that you can use for inspiration. The last thing I want to mention in this video is 1, 2, 3-point perspective is again a mathematical fabrication to create the illusion of space on a 3-dimensional space on a 2-dimensional surface. This is not really a cube. This is just simply shape and line as you've been drawing. This is another way to help create that kind of illusion. Some of the things we've already looked at is overlap. If we overlapped and put a cube in front of this cube, simply by having one in front of the other would help create that illusion of space. Having something in the foreground, the middle ground, and the very background help create that illusion of space, just like the horizon line does. When we get to color, we'll discuss how color can be used to create atmospheric perspective. Atmospheric perspective can be made using value with charcoal as well. Something in the far distance, a mountain in the far distance on a hazy day might be fuzzy. The mountain, something else up in the foreground, a tree, for example, up in the foreground might be much crisper. That feeling of atmosphere as it gets hazy and loses resolution helps create that illusion of space. In color, we can do that with simply warm and cool colors, which is something we will explore in the coming weeks. Warm colors, reds and oranges, will push forward and come forward in space. Cool colors like a blue will recede in space. So when you look at a landscape in color, the cool colors would push forward, the cool colors would recede and naturally create a feeling of space. So overlapping, foreground, middle ground, background, 1, 2, 3-point perspective, atmospheric perspective are all different ways to create that illusion of space on a 2-dimensional surface. So that'll wrap this video up. I want you to work on your developing your skills in creating 1, 2, 3 point perspective, and that will culminate in a surreal, imaginary landscape. It could tell a narrative. This imaginary landscape could be a surreal kind of place that has dream logic that implies a narrative, but certain things are juxtaposed and it's kind of surreal and yet still might make sense spatially. Okay,